In this video, I'll finish up our introduction to graphing, and we were graphing linear equations by plotting points. So we're actually going to look at a second method that we have, and later on we'll do a third. But in this video, we'll look at a second method for graphing linear equations, and then we'll look at graphing nonlinear relations and functions. So it says here, to find the x-intercept for a linear equation, we let y equal 0 and solve for x. And to find the y-intercept, we do the opposite. So we're supposed to find the x and y intercepts and then use those to graph the line. So I want you to notice what we're really doing here is we're finding two special points. So it's not exactly the same as what we were doing when we were using the method of plotting points. In this case, we're looking for two specific points. And it turns out that finding intercepts is going to be very important, not just when we graph lines, but when we graph any kind of function. And so let's go ahead and make our little xy table. And we're going to plug in 0 for x. We get negative 2 times 0. Well, that's just 0 plus 4y equals 8. We're going to get 4y equals 8, which means y is 2. And then let's go ahead and choose y to be 0. And we get negative 2x plus 4 times 0 equals 8. Again, 4 times 0 is 0. So negative 2x equals 8. And we're going to get x is negative 4. And so negative 4, 0 would be our other point. And there's your line. Now, because the arithmetic's pretty easy here, I normally don't find a third point, although some people do recommend that you do. And in fact, most people will find that this is pretty easy to find these points, because when you let x be 0, this part zeroes out, and you can see you're left with 4y equals 8. You can do that arithmetic in your head, or solve that equation in your head. And if you let y be 0, 4 times 0 is 0, and this term cancels out. 0 plus anything doesn't change what's there. And so you can see that negative 2 times negative 4 would give you 8, so that gives us the other point. So for me, this work here is kind of optional depending on how comfortable you are finding the points. All right, let's go ahead, and I would encourage you to do the other one and then watch the video. All right, so if you choose x to be 0, you'll get 15y is negative 10. Notice you are going to get a fraction here. I'm dividing both sides by 15. And so I do get negative 2/3 when I reduce that fraction. And so 0, negative 2/3 is on the graph. Now we do have a fraction here, so we do have to be careful where we place that. It's a little bit, you're kind of estimating a little bit more. Normally you're just putting the points where two lines intersect, so it can be a little more challenging to graph points that have fractions in them. But this one's not too bad. So let's let y be 0. And so now remember, if we're letting y be 0, that means we're finding the x-intercept. If we're letting x be 0, we're finding the y-intercept. Make sure you know which intercept is which, because if I ask you for the y-intercept, I don't want you to give me the x-intercept. All right, so let's see. So when I plug in 0 here, I get 5x equals negative 10, which means x is negative 2. And so let's plot that point and draw the line, and we're good. All right, so here on number 2, it says nonlinear relations and functions. We need to determine if negative 3, 4, the point negative 3, 4, is a solution for x squared minus y squared minus 7. So again, I'm going to make a shell, and I'm going to basically, wherever you see a variable, I'm going to put parentheses, and then I'm going to plug in my values for x and for y. So x here is negative. Remember, this is a point where the first number is an x value and the second is a y value. And so we're going to get negative 3 squared minus 4 squared, let's see, when we multiply -3 times -3, we're going to get 9. And of course, that'll be 4 squared is 16. 9 minus 16 equals 7. That's not true. It would be -7. And so this is not a solution. All right, let's move on to the next slide. So here we have two graphs that we're going to be graphing. And the first one's y equals 2x squared. Notice this is not a linear function. In a linear function, x and y are both to the first power. And so in this case, you have it's actually called quadratic. We have x squared. So, but we're just going to plot points for now. Later on, we'll study these types of functions more carefully. So I'm going to go ahead and make a table. And I'm going to choose x to be 0. You get 2 times 0 squared. Now remember, order of operation tells us to square before we multiply. So 0 times 2, or I'm sorry, 0 times 0, squaring 0, gives us 0, and 0 times 2 is 0. So 0, 0 is on the graph. If we plug in 1, notice we're going to square the 1 first. 1 squared is 1, times the 2 gives us 2. So we have the point 1, 2. And if we plug in 2, again, I'm just choosing small numbers, trying to keep this simple. And let's see, if I plug in 2 squared is 4, times 2 would be 8. Now notice if you multiplied first here, you would end up with 4 squared, which is 16. So order of operations is very important here, that you do that correctly. All right, so we have the point 28. Now if you put in 3, you can see we're going to keep getting bigger, and this thing's going to shoot up on the right side. So I think at this point I've got the right side figured out. Let's go ahead and plug in a negative number, -1. And so we have -1 squared, and we're going to multiply, so that's 1, times 2, we get 2. So -1, 2. And then if we plug in -2, the same kind of thing's going to happen. -2 squared is 4, times 2 is 8. So we have the point -2, 8. And so let's go ahead and plot that. Now you can see the symmetry here. Basically the line, or the y-axis is a line of symmetry. This graph is symmetric with respect to the y-axis. Now we'll get into that in a little more detail later. In fact, you may recall the name of this. It's called a parabola. So let me go ahead and graph this thing for you. And it's U-shaped. So I would encourage you to try number 10, and it's going to be very similar. Just be careful with your order of operations, and then check the solution. So again, we're going to make a table of values. I would start with 0. When you plug in 0, let's see, you're squaring 0, and then you're applying the negative. But 0 squared is 0, -0 is just 0. Of course, 2 times 0 is 0. So we're just going to end up with 3 here. So we have 0, 3. If we plug in 1, here you got to be careful. You're squaring the 1, which is 1. 1 squared is 1. And then you're applying the negative. So this part right here is -1 plus 2. Well, that's 1 plus 3. We're going to get 4 here. So 1, 4 is on the graph. Let's keep on going. The thing about quadratic functions is we need to find that turning point. It's what we call the vertex. And so we haven't found it yet. That's going to be our key, is finding the vertex in a problem like this. So otherwise we could be picking all sorts of points and not getting that shape. It's important that we have an idea of what to expect. All right, so let's plug in 2. And when you do that, you should get 3. And so the point 2, 3 is there. And you can see we've found that turning point. We can see that 1, 4 is our vertex. And so now I'm looking on the left here and on the right, and I'm thinking I want to plug in -1 and 3. So let's plug in -1. And when you do that, you get 0. And when you plug in 3, when you simplify that, you should get 0. And so sure enough, those 2 points are symmetrical with respect to actually this line here. We'll get into this in more detail later, and our graph's going to look like that. All right, and that's it for this video.